In this video, I'll cover the fundamentals of ServiceNow's configuration management database by answering the questions: who uses CMDB? What is it? Where does the data come from to populate the CMDB? When is the CMDB used? Why is the CMDB important? And how does the ServiceNow CMDB work? Who, what, where, when, why, how, ServiceNow CMDB. All you need to know in order to pass ServiceNow CSA certification exam or just level up your ServiceNow CMDB skills. My name is Jeff Teese. I've been a software developer and technical architect for over 30 years, working in all sorts of different languages. And most recently, I've been spending all of my time in ServiceNow. I believe that learning about IT and software development should be fun, and that we tend to overcomplicate things, and that's why I created the YouTube channel ServiceNow Simple, where I've taught thousands of people all about ServiceNow with a focus on keeping things as simple as possible. If you're new to the channel, I would love it if you'd subscribe, as I'm constantly dropping new videos to the channel. Now, let's get to today's topic: who, what, where, when, why, how, ServiceNow CMDB. And we'll start with what. What is the ServiceNow CMDB? ServiceNow defines CMDB as a series of tables and fields that contain all of the configuration items, or CIs, that are controlled by your company, as well as their attributes and relationships. And a configuration item, or CI, is any component that needs to be managed in order to deliver services. And CIs typically include the services and their underlying components. And you can think hardware and software. So, to simplify, a CMDB is a series of database tables and fields that contain all of the components, there again hardware and software, that need to be managed by your company in order to deliver services, as well as their attributes and relationships. And another way to say it is a CMDB is a database that provides a logical model of your company infrastructure, including all of the components and how they're connected and configured to provide services. Or, even simpler, it's a database that knows all about your company's computer stuff and what it's doing. Now that we've talked about what the ServiceNow CMDB is, let's jump into the Now platform and see it. And to do that, open the Now Platform UI, click the All menu item to open the Application Navigator, and traverse to the System Definition Tables module. This module displays a list view of every table that exists within the ServiceNow database. We can see that the default view displays the label and name of each table, the table being extended if applicable, and we'll talk more about table extensions later, when the table structure was last updated, and the ServiceNow application that owns the table. And if we look at the pagination tools at the bottom of the list, we can see that there are a total of 4,605 tables in the ServiceNow database. That's a lot of tables, but ServiceNow is big and it does a lot of stuff. Now let's filter down that list of tables to only include tables that contain CMDB in the name. That leaves us with 923 tables. And this is a fairly accurate but not exact listing of the tables that make up the ServiceNow CMDB. So these are the tables that store all of the different hardware, software, and service components, or CIs, that make up your company's infrastructure. Now let's dig a little deeper. What might you find in your company's IT infrastructure? How about computers? I'll filter down further for tables with computer in the label and CMDB in the name. And we can see there are tables for storing computers and computer rooms and computer room air conditioners and computer room peripherals. How about software? We can see tables to store software and lots of different types of software items. Now let's get even more specific. Let's try Oracle. We'll see 30 tables in the CMDB specifically for storing Oracle-related configuration items that might exist within your company's infrastructure. Okay, while we're here, I want to show you one more important thing. In our definition of CMDB, we stated that it includes all the IT infrastructure components and their relationships. This relationship part is extremely important. The relationships tell us how the items in the CMDB are configured and connected to work together to provide services. This is all handled by a super important table labeled CI relationship and named CMDB_rel_CI. This table contains fields that relate CIs together as parents and children through some defined relationship type. And we'll talk more about how this works later, but I wanted to demonstrate it as it's an important part of our definition. Now that we know what the ServiceNow CMDB is, let's talk where, as in where does the data come from to populate it? And that's done primarily through 3 data entry channels. First, configuration items can be added and updated manually, as in someone typing the data into a form and submitting the record. The ServiceNow user interface includes a form for each of the hundreds of different types of configuration items, and those forms can be used to view, edit, or insert records in the CMDB. Here's the issue with manual entry. It takes a lot of time and effort, and it's a bit error-prone. And it's not uncommon for a CMDB of a mid to large size company to have hundreds of thousands or even millions of configuration items. Manual data entry will probably always be an important option, but it can't efficiently be the primary method of CI ingestion. The second source of configuration items is integrations with existing inventory systems. ServiceNow comes with a broad set of tools that allow connecting to on-prem or cloud-based data stores and importing configuration items into the CMDB. These integrations can be built using supported connectors for things like Excel files or JDBC and SQL, LDAP, REST, and scripts. Data sources can be created to connect and pull the data, transform the attributes as needed, and map values to configuration items on a field-by-field basis. These integrations can then be scheduled to run on a recurring basis to keep data fresh and accurate. Finally, the CMDB can be populated through automated discovery tools. And in most cases, this is the most efficient, accurate, and preferred method of configuration item ingestion. These are tools that automatically crawl along a network seeking out IP-based device connections. Using a set of configurable patterns, devices, software, and relationships can be identified and loaded into the CMDB. Now, ServiceNow offers entire training courses that teach the details around automated discovery. But on a fundamental level, it's important to know this. ServiceNow offers 2 of their own automated discovery tools named Discovery and Service Mapping. The Discovery tool identifies devices and software running on them. They call that horizontal discovery. The Service Mapping tool performs vertical discovery, which identifies the relationships between configuration items and how they work together to provide services. You can also use third-party automated discovery tools like Microsoft SCCM, for example. In fact, you can have multiple discovery tools running to populate a single CMDB. And automated discovery can also be performed on cloud-based networks, which makes it possible to populate the CMDB with CIs running on Amazon Web Services or Google Cloud or Microsoft Azure, for example. So the answer to where the data comes from is often many places. Each source of data entering the CMDB is called a discovery source, and a single CMDB will normally have many discovery sources configured. That's great, but comes with a cost. Anytime you have multiple sources of data loading the same database, you run into the risk of conflict and inaccuracy. It's possible, for example, to have some configuration item, say a computer, that gets entered manually, loaded via an integration, and discovered automatically. When multiple CIs exist within the CMDB that represent a single real-world item, you end up with duplication. It's also possible that some CI gets updated mistakenly with attributes that should be represented through a separate item. They call that overloading. And if multiple discovery sources identify the same item but with different attribute values, the values will be updated repeatedly, flip-flopping, and left by whichever source runs last. To solve these problems, a more accurate diagram of data entering the ServiceNow CMDB looks like this. Before any item or relationship enters the CMDB, it passes through what ServiceNow calls the Identification and Reconciliation Engine, or IRE. The IRE uses a set of configurable identification and data precedence rules, and we'll look at some of these here in a bit, to uniquely identify and match items and manage updates to avoid duplication, overloading, and flip-flopping. Now let's dig a little deeper into the ServiceNow platform to look at how the CMDB works. And to do that, we'll start by looking at ServiceNow's hierarchical database structure. As I mentioned earlier, it's not uncommon for a company's CI count to range in the millions or even many millions of configuration items. That's a lot of data to manage and make useful from a performance perspective. ServiceNow uses what's called a hierarchical database schema to make the CMDB responsive. With a hierarchical database, tables can be created as extensions of other tables, where the table being extended becomes a parent and the extending table becomes a child. And the cool thing is that the child table inherits all of the attributes of the parent table, and these extensions can be created at many levels, enabling the creation of table hierarchies that propagate attributes from the very top of the hierarchy to the very bottom. Let's look at an example. Suppose we create a database table named hardware to store all of our company's hardware items. And we create fields in that table to store the hardware manufacturer and serial number, things that are common to all types of hardware items. We then create two additional tables that extend the hardware table, one for storing printers and one for storing computers, and we add more specific fields to these child tables. In the printer table, we add fields for pages per minute and paper size. And in the computer table, we add CPU speed and RAM fields. Now, because of the way the hierarchical database works, computer items can store values for CPU speed and RAM, as well as manufacturer and serial number. And the printer items can store values for pages per minute, paper size, manufacturer, and serial number. It's very efficient and pretty slick. Now let's take our example one level further and create tables for storing personal computers and servers, both as extensions of the computer table this time. Again, we add more specific fields describing these types of items. And now, a record in the server table can store values for data center, FQDN, CPU speed, RAM, manufacturer, and serial number. And this gets interesting. Records can be added into the tables at any level of the hierarchy. So check this out. Suppose we insert a record into the hardware table. We have one hardware item. And then we add a printer. We now have one printer item and two hardware items. Add a record to computer, and we have one computer item, one printer item, and three hardware items. Add a personal computer record. We have one PC, two computers, one printer, and four hardware items. And finally, if we add a server, and we'll have one server, one PC, three computers, one printer, and five hardware items. We'll pop into the ServiceNow UI in just a second and I'll demonstrate this, but before we do that, I want to mention just two more things. First, tables that exist toward the top of a hierarchy are known as base tables or base classes. So in this case, the hardware table would be considered a base table. And finally, ServiceNow, in their infinite wisdom, had the foresight to slide a base table or class in at the very top of the CMDB table hierarchy. The name of that table is configuration item. Every table in the CMDB that stores configuration items is ultimately a descendant of that configuration item table. It's used to store attributes common to all configuration items, and it serves as a common reference point for accessing CIs throughout the platform. ServiceNow comes out of the box with an application named configuration. which provides the core functionality for the CMDB. And as you can see, there's a lot here. One of the most useful modules is the CI Class Manager. This tool is used to create and update configuration item classes and view or make changes to the identification and reconciliation rules used by the IRE. Clicking the Hierarchy button will display the CI class hierarchy. And this is essentially the hierarchy of database tables that store configuration items, kind of like what we just saw. Within the ServiceNow UI and throughout the documentation, ServiceNow uses the term class to represent a type of configuration item. So for every CI class, there is a corresponding database table. So the hardware class, for example, represents items that get stored in the hardware table. You can see that the configuration item class is at the top of the hierarchy. Every other class is a descendant of configuration item. And the number next to the class is the count of CIs that exists within that class. So our CMDB currently has a total of 2,785 CIs. Now let's scroll down to the hardware class, and we can see that we have 902 hardware CIs. And if we expand hardware, we can see that it is extended by 9 additional classes, one being computer, which is extended by an additional 6 classes, and on and on and on. The deeper you traverse into the hierarchy, the more specific the classes become. Now let's select a class to drill into the details, and I'll choose the computer class. The set of tabs on the left here allow us to traverse through the different sections of the class's parameters. And on the basic info tab, we can see the display name of the class, indication of whether the class can be extended, the name of the database table for the class, in this case CMDB_CI_computer, and more. And with the appropriate permissions, most of these parameters can be modified and brand new classes can be created. The Attributes tab displays a list of the fields that exist within the database for this type of item. Notice that you can filter the list to show all the fields, only the fields that were derived from the parent tables, or only the fields that were added directly to this specific class table. I mentioned earlier that the Identification and Reconciliation Engine, or IRE, uses a set of configurable rules to identify and match items and manage updates to avoid that duplication, overloading, and flip-flopping that we discussed. These next 2 tabs are where those IRE settings are configured for each class. The purpose of the identification rules is to determine if an item of this type coming into this CMDB already has a CI created, or if this is the first time it's been discovered. The way the IRE does that is by searching the CMDB according to the instructions set by the class's ID rule and identifier entries. Each identifier entry tells the IRE how to go about searching for an existing CI. And the IRE will attempt each identifier entry in a series, working from the highest priority to the lowest priority. As soon as a matching CI is identified, the process stops and an update is processed. And if the IRE reaches the end of the list of identifier entries and has not successfully found a match, then an insert is processed and a new CI gets created. So when an item comes into the IRE of type computer, a search will be done on the serial number table, looking for an existing record with the same serial number and serial number type. And if one's found, we have a match and we'll be doing an update. If not, a search will be done on the hardware table, looking for an existing record with the same serial number. If no match, the hardware table is searched again, this time looking for a record with the same name. And finally, the network adapter table gets searched for a matching MAC address and name. Reconciliation rules are only used when a match is found in the identification process. So if a match is found, an update needs to be processed, and reconciliation rules tell the IRE how to go about handling the update. It's here that you can specify which discovery sources can update the items in the class. If multiple sources will be updating, a priority can be set, telling the IRE which source to consider the most accurate. And these reconciliation rules can be set to apply to the entire class or on a field-by-field basis. And data refresh rules can also be defined to tell the IRE to override the reconciliation rules if an item hasn't been updated for some specified period of time and may be getting stale. The Suggested Relationships tab provides the ability to tell the platform the types of relationships that make logical sense for this class. You can expect a computer to be powered by a rack, for example, or to be a member of a cluster. These suggested relationships are then used throughout the platform when building integrations or manually relating CIs. In the Health section, you can set parameters to tell the CMDB dashboard how to measure items of this type related to completeness, compliance, and correctness. And finally, the CI List tab simply displays a list view of all of the configuration items that currently exist within the class. And that's the CI Class Manager application, which tells us a lot about the fundamentals of how the ServiceNow CMDB is implemented. But remember, that's just one of over 50 applications included in the UI related to CMDB. The CMDB Data Manager tool, for example, allows you to create, publish, and manage CI policies to help maintain the CMDB as it grows. And the CMDB Dashboard, which provides a holistic view into the quality and health of the CMDB data. And the CMDB Query Builder, which is a sort of low-code, no-code tool that provides a simple way to query the CMDB for CIs and relationships using a drag-and-drop interface. Let's close by looking at who are the primary users of the CMDB and why it's so important. ServiceNow refers to the who as stakeholders, and these are people who can be positively impacted by the services that the CMDB provides. In the case of a service outage, for example, hundreds of users or customers may be impacted, and the service desk gets involved, and analysts and technicians and support teams. How do you figure out what's wrong and get the service back up and running quickly? Has someone upgraded the application recently? Is it the server that's the problem, or the database, or perhaps a network issue? A well-implemented CMDB could provide instant access to the information needed to quickly resolve the issue, a picture of the impacted service and the hardware and software and relationships that support it. The security team may need to scan database instances for vulnerabilities. Asset management needs to understand the usage of both hardware and software. Auditing needs a listing of all the company's business applications. And operations has to perform a server patch and needs to understand which services might be impacted if complications arise. The list of stakeholders that rely on the CMDB is long, and as for why, it's mostly because much of the modern enterprise is powered by IT, and visibility into the IT infrastructure has become mission critical. For that reason, the tables that make up the CMDB are the heart and soul of the larger ServiceNow platform. Many of the applications that make up the platform are built to be CMDB aware. Incident, problem, and change tasks, for example, contain fields to reference related configuration items. Because the CMDB is such a foundational part of the overall platform, ServiceNow publishes a set of standardized definitions and guidelines for modeling in the CMDB. It's called the Common Services Data Model, or CSDM, and it's designed to align the CMDB's configuration items and the services with your business and strategy. It's essentially a best practices guide for modeling and managing the ServiceNow CMDB. And while CSDM is not really a fundamentals topic, I would recommend everyone read through it to get a better understanding of how the CMDB fits into the larger scope of the Now platform as a whole. And that does it for this video on ServiceNow CMDB fundamentals. I hope you found the video useful. Please remember to subscribe to the channel and drop us some comments. I appreciate your time. Thanks for watching. Remember to keep it simple, and I'll see you in the next video.